This is my new project, a tube amplifier. It's been in work for many years now, and it's finally come together, and it's looking quite good and sounding quite good. Here is the basic rundown of the display. It has a VU meter as well as a spectrum analyzer control, which is quite useful from the front panel. Not too many tube amplifiers have the ability to have an electronic control system built in. Block diagram is made up with the input selector, which is a rotary switch for the multiple inputs. In this case we have phono, tuner, CD and tape. It feeds back to the display board, providing a update to the user what mode it is set at. The display can also feedback a signal to the digital potentiometers to set the input gain if required. This also can go to a bypass switch to bypass the tone circuit control. The unique thing about this particular tube amplifier is the fact that it has a fully integrated tone control and a stereo phase control, allowing me to have full control of the input signal over a conventional design, which would just be a standard power amplifier. The tone control is made up of three parts: bass, treble and mid, which are independently controlled. The stereo phase is quite interesting. It uses a feedback pair where the left and right signals are fed in and subtracted from each other, and the differential signals recombined to allow you to dip out the center channel. And this is very useful when you've got a lot of modern recordings with a lot of compression. You can get rid of some of the compression by notching out the center channel, which is very helpful. Anyway, that passes on to a bypass switch. The bypass switch is from the input. Can pass directly through the amplifier if you so wish by bypassing the tone phase controls. There's also a separate amplifier in there, which is a basic op amp designed to drive the VU meters, and the headphone amplifier for the headphones when they are connected. Another unique thing with the design is the voltage regulator that is made up of a set of tubes using a 90C1 reference tube with two 12AX7s with two pentode bypasses, the L86s, and this does all the regulation, bypassing the need to do anything with solid state, which was a recommendation I was given if you're going to build a tube amplifier, is to look at doing the regulation also with tubes, and it has worked out quite well in this particular design. Front panel controls are made up of the bass, which you're seeing now, the treble control, followed by the mid control, adjusting the mid, high and low. Down underneath we have the stereo phase control to notch out the center pan. Then we have balance, left and the right control, and we have the bypass switch over on the right. And across we go to the direct input. Then off we go one step further to mute for the headphone setup. The input stage is made up of a four-way switch, which is driven into a attenuator pad, then to a digital potentiometer, which drives the input of the 12DW7, which provides the gain, followed by the second half of that same tube, which is just a simple cathode follower to buffer the output for the tone circuitry. The tone circuit is made up of three sections: your mid, your bass and treble, and there on the output there is a gain stage made up of a 12AX7 to pick up the losses within the tone circuitry, and that is then buffered off to go into several other parts of the circuit, such as your long tail pair, where the two signals are fed in to the opposing sides of the network, and therefore you get the plus and minus of those two differential signals that have come out to the output, which are then combined back further down the chain, as you see here with the combination of the resistor networks, followed by your balance control, which feeds into the grid of each tube that outputs the left and right recovered signal to be fed on to the power amplifier stage. Power amplifier circuit, where the first triode of the 6BM8 is your negative feedback input, followed by the second triode, which is the phase splitter, which then drives both outputs in class A opposing each other and combining in the output transformer stage, as you see here. Here is the PCB layout showing the components on the underside of the board. On the top is the tube sockets with the heater connections to the back panel. Here is an image of the heat shield that sits between the circuit board and the tubes that sit on top. Here is an issue I had with the case when I brought it, is that the upper lid on top of the case didn't have sufficient ventilation to circulate air. Therefore I placed it with this new metal plate that had pre-drilled holes in it, which rectified the issues I had with the ventilation. Here is a view of the inner workings of the amplifier, showing the tubes glowing away quite happily on the top there. The one on the far left and the one on the far right are your audio matching transformers, which in this case is 10k through to 8 ohms. The one to the left of the middle, that is just an extra transformer I need for the front panel and providing heater voltage for the regulator stage, and the big transformer to the left of centre, that tries all the other circuitry. There's simply no way I can actually demonstrate how good this amplifier sounds, but I can do the second best. I'll play a small snippet of a song that I've been writing called Lost in a Maze, and it's amazing what you can do these days with some AI tools. Hope you enjoy as a outro.
In darkness deep, where silence intertwines, we wander this maze, lost in tangled designs. A spiral of thoughts, a truth we can't evade, searching for answers in this intricate cascade. Though the path is winding and the way feels long, with each step we take, we'll find where we belong.